So hi, my name is Khalid. Today I'm making this demo video of me teaching physics. Okay, so for that I choose to teach about temperature and heat. This chapter is discussed on grade 9 student textbook, physics student textbook on chapter 7. And today I'm going to go through some terms like heat, temperature, thermal equilibrium, thermal expansion, about scale of measurement of temperature. Yeah, that's enough. I think I will go through roughly through all of that, and by the end of it, we will be able to explain the difference between heat and temperature. Right? That's the goal, and I hope we will achieve our goal. Right? So let's get started. What does heat mean? Heat is just a transfer of energy from hot object to colder object. Okay, when there is a hot object and there is a colder object, and when the two have a physical contact, there will be a flow of energy from the hotter one to a colder one. That's what we call heating. That's what heat means. Okay, and this heat energy is measured in joules. Okay, whereas temperature is a measure of uh, the kinetic energy of the particles on a matter. Okay, we know that matter. We can find matter in three states, right? There is a solid state, there is a liquid state, there is a gaseous state, right? On a solid state, the bond between these particles is tight, right? They don't easily move around, right? But in liquid and gaseous states, the particles move uh, freely. They have more space to move around, right? It's more so on the gaseous state, right? So uh, when we hit a solid object, or uh, when we hit a solid object, the particles don't have enough space to move around, so they usually vibrate. Okay, so what happens is when we measure the temperature of a solid object, we are measuring the speed of the particles vibrating. Okay, when there is a high speed of the particles vibrating, we say that the temperature is higher. If the vibration is slow, we say that the temperature is lower, right? Whereas, yeah, it's the same. The same is true for liquid and gas, right? When the particles are moving around fast, okay, if the particles have high kinetic energy, we say that that object is that object has higher temperature. Okay, same on gas. Okay, if the particles move high with high speed, or if the particles have high kinetic energy, we say that that matter has high temperature. Okay, so that's the difference between those two. Heat is an energy, temperature is the measure of the speed, or the average kinetic energy of the particles. Okay, so um, I think that's that is a difference. Okay, there are 10 measurements that we use to measure the temperature of. There are some scales that we use to measure the temperature of matters. Okay, there are three of them. There are the mostly known are Kelvin, degree Celsius, and degree Fahrenheit. Those three scales are used widely for to measure the temperature of an object, right? So we know that by the degree Fahrenheit is mostly used in USA. It's not mostly used around the world except the USA, right? Even the weather forecast, if you have seen some videos of the American media, they forecast the weather with degree Fahrenheit, right? But most of the world use degree Celsius and Kelvin. Uh, Most of the physicists and scientists use this scale around the world, right? Kelvin and Celsius are the mostly used scales, right? So um, yeah, when we say what is the lowest temperature do you think in the world? Huh? The lowest temperature means if the particles of the the matter that we are measuring, right? If the particles are not even moving slightly, there is absolute zero movement of the particles. We call that absolute zero, or zero Kelvin. Okay, the other name of zero Kelvin, the absolute zero, is zero Kelvin. 0 Kelvin means the particles have absolutely zero movement. There is not even the slightest movement of a particle. There is, yeah, obviously there is no real object on the world, right, with absolute zero temperature. Even the coldest parts of the world have at least some negative, some degree Celsius or some Kelvin, right? By the way, the 0 Kelvin means negative 273 degrees Celsius. Imagine that, right? It is very cold. You can't even imagine how cold it is, okay? It is, the particles have absolute zero movement, okay? We say that temperature is the measure of the movement of the particles, right? When there is absolutely zero movement, there is that. What do we mean? There is no lower temperature than that, okay? The lower temperature is 0 Kelvin. So when you hit the object, it starts to gain heat. It starts to gain temperature, okay? So uh, so we have to keep that in mind, okay? Uh, okay, we can also, yeah, the other term is thermal equilibrium. Uh, yeah, thermal equilibrium. Let's first discuss thermal expansion. Thermal expansion means uh, the increase in size of the substance, okay, as a result of heating. When we heat an object, and if the size of that object increases because of the heat that we apply, we call that thermal expansion of the object. Okay, we see it if for an experiment. If we tie a balloon, okay, to make sure that there is no air that's coming to it or out, and if we put it on the sun, okay, after some time, we see that the size of the balloon starts to expand. Okay, the size starts to be bigger. Okay, we call that thermal expansion. Why do you think that happens? That happens because the movement of the particles on inside the movement of the particles in the air inside the balloon are moving faster because there is heat applied from the sun on the balloon, right? That causes the particles to move faster and faster and faster. And when there is no enough space, there is no more space for the particles to move, they burst out of the balloon and the balloon explodes, right? So that's what we call thermal expansion. Okay, uh, when we uh, when we talk about thermal equilibrium, uh, it is the situation where there is no net movement of energy between two objects or two bodies. Okay, this is how thermometers work. Okay, this is very interesting. Okay, do you know thermometer that doctors use to take our temperature, our body temperature? No, the little equipment that they put in our armpits and take our temperature. Yeah, that that works by the principles of thermal equilibrium. Okay, and you can also feel it when they put it first on our armpit. We feel cold, right? Our body temperature is what? Our body temperature is higher than the temperature on the thermometer. But after some time, we feel we the cold starts to decrease, and we after some time we don't feel anything, right? That's because the heat energy that flows from our body starts to flow to the thermometer. Okay, then after some time, the temperature in on our body and the temperature on the thermometer reaches a thermal equilibrium. Okay, they reach at the same temperature. Okay, that is when the alarm on the thermometer starts to sound, right? Starts to beep, and that is when the doctor took the thermometer out of our arm and read the number, right? Because that number is exactly uh, what our body temperature is at. We reach a thermal equilibrium with a thermometer. Okay, that's how doctors use thermometers, right? That's the application of this the physics that the physics world uh, provides for the world, right? So this is a very interesting topics. I think we go through. We don't have enough time, so we go through some of the main things. I hope we understand the difference between heat and temperature. So until next time, hopefully. Thank you.